Okay. Now put here this is equal to minus 4 in above equation. We get minus 3 is equal to c into minus 2 into minus 6. That is minus 3 is equal to 6 into c. Therefore c is equal to minus 3 by 6. That is 1 by minus 1 by 2. Once we calculate all these values, we have to put all these values in original equation. Those we have call it as 1. Okay, therefore put these all these values in original equation. We get our original function is equal to a upon s plus 3, that is a value is 2 by 5, b value is 1 by 10, and c value is minus 1 by 2 divided by corresponding factors. Now this is the called partial fraction method. That means the given fraction we have divided into addition of factors, simple factors, so that we can calculate the inverse Laplace transform easily. Okay, that's why we have taken this help of partial fraction. Now taking what is our question, we have to take inverse Laplace. That's why next step will be taking inverse Laplace transform or inverse Laplace both side. What we get, L inverse of, this is our original equation, is equal to L inverse of this total function. Now take L inverse inside and take constants outside from each term. We get 2 by 5 L inverse of 1 upon s plus 3 plus 1 by 10 L inverse of 1 upon s minus 2 plus or minus 1 by 2 L inverse of 1 upon s plus 4. And these three are simple equations or simple terms. This is e raised to, L inverse is e raised to minus 3t, this is e raised to plus 2t, and this is e raised to minus 4t. This is called partial fraction method for all the terms if denominator contains all the linear factors, type 1 method. Okay. Now here consider one more example. This is your homework. Okay. The inverse of 1 upon s into s plus 1 into s plus 2. This is homework. Answer is this. There are three. Though here only contains yes, it is also a one linear factor. Okay, like yes plus 0. Okay, that's why it is one factor. This is second, this is third. There are three linear factor, so that you can take a upon s, b upon s plus 1, c upon s plus 2, and calculate as above. You get this answer. Okay, now next consider this example. Numerator is s square plus 2s minus 3. Denominator contains s cube minus 7s plus 6. Now whenever cubic or quadratic, cubic, or raised to 4 powers are there more than 2, then we have to factorize this term, so that we come to know which are the brackets there. I mean, either they should be for partial fraction, either they should be linear or quadratic. Okay. Now here s cube is there, that's why we have to factorize this term. How to factorize s cube terms? Or more than power, if suppose power is uh, more than 2 quadratic factors, we can easily calculate. Okay, then there, if there is indice more than 2, then we can use, this is the method, we know this is a division method, synthetic division method. This is called, we already know this is synthetic. You don't need to write this synthetic method in example. Okay, now what is this method? Just take this plus sign here and put this, we have to factorize this. Okay, that's why we have to write coefficient of s here using decreasing order. S cube coefficient is 1, that's why you write here 1. Here s square is absent, that's why we have to write 0. Don't skip the expression, we have to go by the descending order. Okay, s square is not there, that's why we have to write 0. Don't forget that. Now s coefficient is minus 7 including this sign, and last constant term, that is 6. Okay, this is our first step. Now we have to write here, start from 1. We have to write 1, then if 1 is not there, then minus 1. If minus 1 is not there, we get plus 2, minus 2, 3, minus 3, and so on. We have to go by both the plus minus both side. Okay, now if we write this, then what is the next step? You have to take this number as it is here. Okay, whatever the number it is, you have to take as it is here. As it is here. Now multiply these two numbers and write here. 1 into 1, 1. Now take the addition of these two. 1. 0 plus 1, 1. Now take multiplication of these two. That is 1. Now take addition, minus 6. Now take multiplication of this right here. Now addition of this last term and the last number should be 0 until we have to do this all these things. Okay, in the exam first you do the rough things, then whatever the number you will get the answer for that. This number means this is a factor of this is the root of this equation or factor, or this is a factor of this expression. Okay, once you get 0 here, then you can fare in the original example. This is our first step here to find out the factors here. Okay, now here we get one factor only using this synthetic division. Once you get 0, write down the factors here. This is, you have to take opposite of this. Subtract this from yes minus 1. If it is plus, you take minus. If it is minus, you take plus. That is yes minus 1. That, and remaining factor should be recognized from these three numbers. Remaining factor will be start from s cube minus 1, 3 minus 1. That is, remaining factor will be the quadratic equation, and coefficient of this quadratic equation will be these numbers. Okay, that means s square coefficient is 1 plus s coefficient is also 1, and last number is minus 6. Okay, this is the other factor of this expression. Once already one we get one factor, now remaining two factor, of course s cube is there, that's why we have three factors here. Okay, three factors if they are linear, or one quadratic, one linear, in that sense. Okay, that's why remaining two factors can be calculated from this. How to calculate the factors from quadratic equation? It is very easy. We can factorize that. Minus 6, the factors are 3 minus 2, so that addition is plus 1. That's why factors are s plus 3, s minus 2. So that in this way we get the factors, three factors of this expression. This is called synthetic division method. Okay, synthetic method or synthetic division method. Okay, now once we factorize this denominator, write down this denominator here. What we get then? Given example becomes s square plus 2s minus 3 upon s cube minus 7s plus 6 becomes numerator as it is, denominators contains three factors, s minus 1, s minus 2 and s plus 3. Okay, now our partial fraction method start from here. Okay, now let this is equal to, these are three linear factors, a upon first factor, b upon second factor, c upon third factor. And this example you can solve it by earlier method. Okay, now these are some homeworks for you. This is one homework, this is also homework, and this is the 33 example is a homework also. In this 33th example, if the expression, denominator expression, doesn't contain any constant, if it is contain every s term, then take s common from the denominator. You get here s common, s square plus s minus 2, in this way. Okay, and this factor you can, it is a quadratic factor, you can factorize that, and you can solve this by partial fraction method for type 1. Okay, so these are some examples depend on the type 1 method here. Okay, now move to type 2 or quadratic next type. Consider this is the example where we have to find out inverse Laplace transform of this expression using partial fraction method. Question is same. Now if you observe these two, This is one linear factor. For this factor, type 1 rule is we have to apply. And for this second, if you observe this, you cannot factorize this. Okay, we cannot factorize this because it is not a multiplication of two factor. Okay, we cannot factorize. That's why just we have to keep that as it is. If we'll keep that as it is, then if you observe denominator, there are two factors. First one is linear, that means type 1, and second is quadratic factor. Okay, for quadratic factor there is rule number 3. Okay, this is quadratic factor. How to write quadratic factor? As plus b, in that fashion. Okay, that's why for this factor we have to write as plus b type of we have to use that type. Now consider, let us see how to solve this. Consider this expression is equal to a upon s plus 1. First factor is it is normal linear factor, that's why we have to take a upon s plus 1, plus this is a quadratic, that's why we have to take bs plus c. Next, everywhere you have to take next constant a b c d and so on, that's why it is bs plus c upon second quadratic factor. Now it is there are only two terms, that's why cross multiply. Take LCM. LCM means the denominator as it is. Okay, a into the this quadratic factor plus bs plus c into this linear factor s plus 1. Okay, now next step we have to compare the numerator. Okay, because denominator are same, therefore 1 is equal to numerator of LHS side, 1 is equal to numerator of our RHS side. Okay, and okay, now here while writing down these factors, just take multiplication of all the terms. That's why it is as square plus 2as, first number, then alphabet, then s value, s expression. In that way you have to write 2as plus 2a plus now bs, multiply with factor bs square plus bs, now cs plus c throughout the multiplication. Okay, now here in earlier type we have to put values of s so that we can calculate the constants. But if it is quadratic there, then you have to use the other method to calculate the values of the constants. In this case also you can put value s is equal to -1 and calculate one factor, but I'm telling you the other way also. Okay, see, we have to compare the coefficients from the both side of the equation. How to compare? Start from the highest expression of s, highest indice of s. What is the highest indice on the RHS side? It is s square only. That's why these are the two s square coefficient. Just underline the same coefficient. And this is s square, this is s square only, so that we can easily recognize. Then comparing the coefficient on the both side. See, if this number is equal to this polygon, this is the one polygon. Okay, it is expression in yes and it is equal to 1. What is the meaning of this equation? This equation meaning is the both side the coefficients must be equal. Okay, suppose this coefficient of s square must be equal to coefficient of s square on both the side, LHS and RHS side. Coefficient of s on the LHS side is equal to coefficient of s on the RHS side. Okay, these are the this is the meaning of this equation. Okay, that means comparing the coefficient on the both side, what we get? First start with s square coefficient, underline that. This is 1, this is second s square. A plus b is the coefficient of s square here. That's why a plus b equal to coefficient of s square in the LHS side. If s square is absent here in the LHS side, we have to take 0. Okay, that's why a plus b is equal to 0. Second equation start from we have to compare the coefficient of, now next indice, that is yes. Yes, how many yes coefficients are there? Just underline with the other notation, that is curly underline here. Here also curly underline, yes coefficient, here also yes coefficient. There are 3 yes coefficient, that's why we have to compare these 3 now. 2a plus b plus c, 2a plus b plus c is equal to LHS sides yes coefficient. There is no yes here, that's why we have to take 0. Okay, you can write this first and this 0 here also. Okay, like equations. Now last remaining are the constants only, don't underline that. Just 2a here, 2a plus c. Okay, these are the constant terms where yes variable is not there. That's why 2a plus c is equal to, the LHS side constant is 1. That's why now 2a plus c is equal to 1. Okay, this is very important step, comparing the coefficient on the both side. Wherever yes is absent, whatever the indice here, you have to take 0 only. It is as simple as that. Now if you observe these equations, you can solve easily, and we have to find out values of a, b and c by solving these 3 equations. From this above equation, if you observe, these are very easy. From above equation, b is equal to minus a. Okay, put this minus a in this equation, we get 0 is equal to 2a minus a plus c. 2a minus a plus a, that is 0 is equal to a plus c. This is one equation in a and c, and this is the second equation. Third equation is in a and c, we can simultaneously solve. This is 1 is equal to 2a plus c. Now we have to subtract this, because to get cancel c, you have to subtract. All the numbers gets reverse, opposite in sign. This is minus 1, this is minus 2, minus a is minus a, and this is gets cancelled. That's why a value is plus 1. Once we get one value, you can get other value easily. Okay, now put this value a in every example. In every equation, put value here a, we get b is equal to minus 1, and put here anywhere in here c is equal to minus a. From here we get c is equal to, or here from here c is equal to minus a, therefore c is equal to minus 1. Okay, these are very easy equations, you can easily solve that. Now put all these values in above equation. What we get? Okay, now we get, putting all these values in our original equation, we get, this is our original equation, is equal to 1 upon s plus a value is 1 upon s plus 1, b s plus c, b value is minus 1, c value is minus 1, minus s plus minus 1 upon second quadratic factor. Okay, now now simplify this. Minus minus take in the middle, we get 1 upon s plus 1 minus s plus 1 upon s square plus 2s plus 2. Okay, this is our partial fraction method. Now our original equation is finding out the inverse. That's why taking inverse Laplace transform both sides, we get L inverse of this expression is equal to L inverse of this total term. Okay, now take L inverse inside to the each term, we get L inverse of 1 upon s plus 1 minus L inverse of this term. Now this inverse is very easy, e raised to plus 1's opposite minus t. Okay, minus 1t plus L inverse of this term as it is. Now if you observe this, we have to adjust the denominator into a perfect square. We have already seen such type of example. You have to solve this separately. Now consider this L inverse of s plus 1 upon s square plus 2s plus 2. Which square here we can adjust? S square, that is yes. S coefficient is 2 by 2 is 1. Okay, we already done this type of example in earlier lecture. S plus 1 bracket square is there. Now expand this, s square plus 2s plus 1, we take extra, that's why we have to subtract that extra from this number. 2 minus 1 is 1. Okay, Now this is our s plus 1 in the numerator itself is adjusted. That's why we have to take first shifting property we have to use here. E raised to which number? Plus 1 opposite of that minus t. Take outside by using first shifting property. And what we have to do here? Just delete this plus 1. We get L inverse of s upon s square plus 1. Okay. This is the first shifting property we have already seen in last lecture. Now what is this? This is a cos. Cos, this is simple cos t. Okay. This is the inverse Laplace transform of this second function. Now put this value in here. Our original equation is L inverse of this term is equal to e raised to minus t plus this answer is e raised to minus t cos t. Take e raised to minus t common, we get e raised to minus t 1 plus cos t. Understand? Okay. Now consider next. Next example, 35th example, n inverse of numerator is 2s square minus 1 and denominator contains two factors. Both are quadratic factors, that's why type number 3 we have to apply here. Now consider 2s square minus 1 given expression is equal to, for first factor, consider as plus b upon s square plus 1 plus cs plus d upon s square plus 4. Okay. Now cross multiply, we get multiplication is LCM here, or this just copy this denominator here only. When cross multiply, we get this term. Now next step will be comparing the numerators. Therefore, we get numerator on LHS side 2s square minus 1 is equal to numerator on the RHS side this total term. Okay. Now multiply throughout the term, we get as cube plus 4as plus bs square plus 4b plus now these two cs cube plus cs plus ds square plus d. Okay, throughout multiplication. Now to what we have to do? Comparing the coefficient on the both side of the equation. What is the coefficient? Highest coefficient of highest indices? S cube. Underline that. S cube is here and S cube is here. What is the coefficient? A plus C is equal to, here S cube is not there, that's why we take 0. Now S square. S square is here and here. Okay. What is the coefficient? B plus D is equal to, here S square is 2 coefficient. That's why it takes 2. Now S coefficient. Where are S square? Double underline. S square. Yes only. Double underline. Okay. There are only two terms. 4A plus C. 4A plus C. And S is absent here. That's why we take 0 coefficient. Now last non-underlined terms. That means constant sum. Which are 4B plus D. And constants on the LHS side is with sign minus 1. Okay. Now we have to solve this 4 equations. It is very easy. First and third equation we have to solve in A and C. Solving this, subtracting, we get A is equal to 0, C is equal to 0. Okay. Now second and fourth we have to take, subtract this, we get B is equal to minus 1 and put this value B anywhere, we get D is equal to 3. Okay, we have calculated 4 values. Now put these 4 values in original equation number 1. We get 2a square minus 1 upon the factor is equal to as plus b. A value is 0 minus b value is minus 1. Okay, upon first factor s square plus 1 plus 3 into, here is the equation, this is the equation. Okay, we have to put this value only here. And next is plus 3 minus plus this is 3d upon s square plus 4. Okay, next you can easily find out the inverse both side, we get the answer. Okay, main step is you have to, this is the important step, you have to find out constants and before that these comparing the coefficients. Okay, now this is the homework. Only one step is remaining here. Okay, now consider L inverse of s upon s plus 1 bracket square s square plus 1. We have to find out inverse using partial fraction method. Now if you observe these two, this is very easy. This is the type 3 quadratic factor. If you observe this is linear but it is repeated 2 times. Bracket is linear but it is repeated 2 times. That's why type number 2 here. What is type number 2? This is type number 2, where function or expression, the factor is repeated, suppose 3 times here. We have to take like this. This is the type number 2. If 3 is there, you have to assume 3 constants. Here in the example, 2 is there. Bracket square is there. That's why we have to take only 2 constants. Total number of constants are here 2 and here 2. 4 constants. Okay. Now write down the expression. S upon s square, s plus 1 bracket square, s square plus 1 becomes a upon first factor s plus 1 plus b upon second factor, which is square s plus 1 square. Okay. This is the type 2. Plus this is a quadratic, that's why cs plus d, next coefficient a b c d, cs plus d upon quadratic factor. Okay. Now next, LCM, take LCM on both side. LCM is this term only. And now how to write the numerator? A into, just delete this factor from this. One factor get less, we get s plus 1 into s square plus 1. Plus b into, just delete this factor from this, we get s square plus 1. Plus cs plus d into, this delete this factor from this, we get s plus 1 bracket square. Okay. Now comparing the coefficient, comparing the numerator both side. Okay, we get comparing the numerator actually. We get s is equal to numerator of this LHS side is equal to numerator of this whole side. Okay. Now in this example, I'm going to tell you the other method also. Okay, the easiest way, most easiest way. You can use this method in earlier example also. Okay. Now we have to find out wherever we have to recognize the linear factor here. Which one is linear factor? Here s plus 1 is linear factor. Only one factor is linear here. That's why we can calculate one constant using the linear uh, linear type examples, like linear type example. Okay, what was that? Just put the opposite number here. S is equal to minus 1 both side. What we get? Minus 1 is equal to minus plus 1 here also. That's why these two gets cancel. Okay, these two gets cancel and this b remains as it is, or b becomes non-zero. That's why b is into s square, that is minus 1 square plus 1 plus 1. That's why b is equal to minus 1 by this 2. One number we can easily get, we can easily calculate by earlier method, which is linear method. Now for the second and third constant, that is b, a and c, we have to multiply this, and using comparing the coefficient you have to make the equation.